This is 1.5, the least common multiple. A common multiple is where we have multiples that are shared by two or more numbers. A multiple would be a number that we could end at by counting by a certain number. The least common multiple is the smallest of those multiples. So the smallest one that two numbers share. So to find the LCM, you can list the multiples or you can use prime factorization. If we're going to list the multiples, let's do that first. So we're going to find the LCM between 8 and 6. So to list the multiples, I'm going to count by 8s. And I'm going to stop here at 48 because we know for sure that they're going to have a match at 8 times 6. Now in listing all the way to 8 times 6 for counting by 6s, I know I can stop there. Now I'm looking to see which is the smallest match they have, and that is 24. Between 3 and 7, counting by 3s, I'm going to stop at 3 times 7. I know for sure that they're going to match there. That's what multiplying means. Then for 7 times 3, my only multiple here is 21, so multiplying the two together is 21. If both of your numbers, Okay, between 17 and 5, I'm going to count by 17s until I get to 17 times 5, so that's 1, 2, 3, 4, 5 times. And for counting by 5s, if I list it out to 17 times, I can see the LCM is 85. Now to use prime factorization, we're going to write out the prime factorization of each number. Then we're going to multiply the factors the most amount of times it appears for a number. We're going to use something that I call the chocolate bar method. So to find the LCM between 30 and 42, if I write out their prime factorizations, I have 2 times 3 times 5 and 2 times 3 times 7. Now, to make this chocolate bar, I'm going to have a line for 30 and a line for 42. And I take their prime factorizations and write them out. 30 is 2 times 3 times 5, and 40 is 2 times 3 times 7. And I line them up so that things that they share go in the same columns. Things they don't share will have an empty spot for the other one. Now I bring one from every column down and multiply them all together. And I get the LCM is 210. I think using the prime factorization is a little bit easier than counting by those numbers. Counting by 42s is not going to be super easy or quick, so prime factorization is the way to go. Now for 35 and 42, prime factorizations are 5 and 7, 2, 3, and 7. Make your line for 35 and your line for 42. It's best if you can write them all in order. So for this one, I would start with 42 because it has smaller numbers. 2 times 3 times 7. Leave a spot because they do not share 5, but they share 7. Then I have 2 times 3 times 5 times 7 to make 210. For 20 and 32, making my prime factorizations, I can see I have a whole bunch of 2's. So let's list out 32. Oh, we're also doing 12. So I'm going to list out 32 first and fill in all those 2's. For 20, 2 times 2 times 5, and 12 is 2 times 2 times 3. They all share 2 2's. So I have a column full of 2's and another column full of 2's. Bring down one from every column and multiply them together. And then we can get 480 is our LCM. To find the LCM between these three numbers, prime factorizations, make your line for 18, 2 times 3 times 3. 42 is 2 times 3 times 7, and 22 is 2 times 11. Bring down 1 from every column. We get 2 times 3 times 3 times 7 times 11 to get 1,386.